Alum video number 2. Same as number 1. I have no crystals in here. There's some weird fuzzy looking substance that kind of floats around whenever the solution is moved. My guess for why there are no crystals is because I've been having my solution sit on the top of my refrigerator, which is pretty warm because it sits right next to my heater. From now on I will put it on my windowsill where it will be cold and it'll help the crystals develop. So for the theoretical yield, we have the math right here. We had 1.001 grams of aluminum with the molar mass of aluminum of 26.981 grams per mole, which told us that we had 0.037 moles of aluminum to start with. Using the stoichiometric ratios in the equations here, we found that we had, using the molar mass of alum, 17.55 grams of alum at the end as the theoretical yield. Now our actual yield was 10.255, which is a pretty big difference. Our percent yield was 58.43. What would explain our percent yield being so far away from 100% is when we were doing the experiment, we only needed 4 grams of the solid alum each to make our solutions, so we needed 8 grams total. We were having some trouble procedurally getting the solid alum out of the solution when we had to drain it, and so we poured, once we had most of the alum solid in the funnel, we poured some of the solution out, which was something that our TA suggested, and because we already had enough that we needed to make our solutions. But by doing so, we obviously lost some of our alum that would have been floating around in the solution. So we didn't end up with all 17.5 grams. We only ended up with 10, which was more than enough that we needed. And that explains the percent yield disparity. Tune in next week for installment number 3.